video, but if you hit record, we're good. Thank you. All right. Good morning and welcome to the Pat and Math Conference and this session, The Importance of Language in the Math Classroom. My name is Melissa Klug and I am joined by my colleague, Jared Campbell. Before we start, I just want to remind you that if you are using the Sched app, the announcements for this conference are under the Info tab. All announcements for today are also on the conference website, as well as presenter bios and handouts. And Jared just put that in the chat for you. Note that not all sessions have handouts, but there are session handouts provided for this one, and you can access it with that link in the chat. To enable the closed captioning, please click on the CC icon on the toolbar. And at this time, it is our pleasure to introduce you to Dr. Sarah Powell.
All right, thank you so much, Melissa. Good morning, all. So nice to join you here today for this session about the importance of language in the math classroom. We're going to go ahead and get started. So as Melissa said, my name is Sarah Powell. I'm an associate professor at the University of Texas at Austin. Here I provide my contact information if you'd like to continue these conversations about math language or just math in general. So you can reach out to me via my website, via my email address, or find me on social media. And as Melissa noted, there is a set of handouts that I created for today. Those handouts are really just meant for you to make notes. They look a little bit like this. And my contact information is on those handouts as well. So today I am going to do some of the leading of this session, but I would also like you to be a participant if you feel comfortable to do so. So we are going to use that chat box. And so if you feel comfortable, I'd like you to open up that chat, say hello, maybe introduce yourself, and tell us a little bit about your role as an educator and what is some of the math that you support? Do you support Tier 2 intervention or do you support grade 4 math? Tell us a little bit about yourself. I'd like to see who's here, and I'm sure some other people attending the session would like to see who's here as well. So go ahead and open up the chat and do that. And this will be also an opportunity for you to, if you open the Sched app, this entire presentation and those handouts are available through the app. So this is a nice break for you to get those if you want to take any notes or do any of that. So I'll give you time to do that. So welcome all. So nice to see you all here today. All right, so today we are going to talk about math language. And math language is an important part of the math instructional platform. So when I think about the instructional platform, this is your jumping off point for really, really effective math instruction. And so the platform should be full of things like explicit instruction, math language, which is the focus of our session right now. But we should also think about using multiple representations with students to make sure that students are really understanding the concepts and procedures of math. And then we also want to put in strategies that are important for building effective math instruction. And some strategies that might be important to put into your instructional platform are building fluency and a focus on word problems. Speaking of word problems, this afternoon, I will be doing a session on word problem solving. So if you want to dig into that more deeply, please join me in that afternoon session. But right now, we're going to focus on that green area, which is the importance of math language in the classroom. So math language fits in right here in our instructional platform. While I am going to talk just about math language today, I do want to emphasize that math language is often used as you use your explicit instruction. So we can't really just ever focus on math language. We have to be thinking about, well, how are we explicitly teaching and practicing math language with students? So I just want to have a gentle reminder of that really none of these components of the instructional platform are done in isolation. So let's get started with our presentation. I'm going to be on the first page of the handout packet if you're making any notes there. So a little bit about math language. So the research on math language is fairly strong. And so I pulled out a few things from the research literature that talk about math language. So if we look here at the top rectangle, what we see is that there is a significant correlation between students' understanding of math vocabulary and their math performance. And so that might not be a surprise to many of you, because when students have stronger math vocabulary, that likely means that they have a better understanding of mathematics and are able to show off that mathematics knowledge. And importantly, math vocabulary appears really important for word problem solving performance. So that is also probably not a surprise because many word problems have a lot of math vocabulary in those word problems. And so a better understanding of that vocabulary might lead to a better understanding of those word problems. Another thing from the research that we have seen around math language is that early math language, particularly early math vocabulary, particularly math vocabulary related to numeracy and spatial understanding, that is related to students' mathematics performance as well as their understanding of literacy. So math vocabulary really can go beyond just mathematics. And then really importantly, which is probably why a lot of you are here today, is that students who experience difficulty with mathematics vocabulary and difficulty in mathematics in general, those are the students that often show lower mathematics vocabulary performance. And so that means we need to provide some targeted instruction when students struggle with math vocabulary, knowing that math vocabulary is important for math performance and is important for word problem solving and is important for a lot of other things in mathematics. So, math vocabulary. Today we're going to focus on math vocabulary, particularly across grades K through 8, although some of these conversations would be important for pre-K as well as high school. And when we think about math vocabulary, there's a lot of math vocabulary. So these are some math vocabulary counts that we accrued from several different textbook series across grades K through 8. And what you can see here is that in kindergarten, first and second grade, if you go to a glossary that is included in one of those math textbooks, you are likely to see around 100 to 130 different mathematics vocabulary terms. So even our kindergarten students are responsible for knowing, at least by the end of the kindergarten year, well over 100 math vocabulary terms. That is a lot. But then we see a very large increase in grade 3. And probably some of you know why. Grade 3 is the year that we introduce fractions to students. There's a lot of fraction vocabulary out there. We also start talking about multiplication and division, lots of new vocabulary introduced there. And so if you support students in grades 3, 4, 5, which I see in the chat, there are a lot of you that do that, your average student in those grade levels may be responsible for knowing anywhere from 300 to almost 400 different math vocabulary terms. And then we see another slight increase as we go into the middle school grades. So in the middle school grades, those students typically are responsible for knowing anywhere from over 400 to over 500 math vocabulary terms. Now, many of these terms accrue from one grade level to the next, but when we see these increases, that means there are new vocabulary terms coming into play, and then some vocabulary terms are fading out, maybe especially vocabulary terms related to early numeracy. We aren't going to see those continued in the late elementary or middle school grades, and maybe some vocabulary related to addition and subtraction. That's not going to be emphasized as much in middle school, even though students still need to have an understanding of those terms. So there's a lot of math vocabulary, and students have to use that vocabulary in a number of ways. So in the math classroom, as students are working with you, students do a lot of listening. So they're listening to you, they're listening to their peers. Many times they might be listening to a video that involves an understanding of vocabulary. Students do a tremendous amount of speaking in the math classroom. Hopefully they do, as they engage in dialogue with you or their peers, and they're providing explanations and telling you what they think. And so that involves an understanding of math vocabulary. Students also do a lot of reading in the math classroom. Even in the earliest grades, students are seeing words and then terms and then sentences and then word problems. But there's a lot of reading that students do through word problem solving or as they read textbooks, or maybe some of your students are reading closed captions. So reading is important and vocabulary is a key part of that. And then there's also a lot of writing in the math classroom, not only the writing of numbers and symbols, but the writing of words, sentences, and paragraphs. And all of those things involve an understanding of math vocabulary. And when students don't have a good understanding of math vocabulary, it's going to make each of these skills more difficult. And it's likely going to mean that some of your students stop being full participants in your math classroom. And so that's why the session that we're doing here today on math language, and specifically we're going to focus on math vocabulary. That's why it's an important focus point and really important to explicitly work on with your students. Now, there's a lot of reasons that students struggle with math vocabulary. So I'm going to share some that come from a really nice article by Rubenstein and Thompson. And in the chat, if you have some other examples of these, I'd love for you to add those to our conversation. But let's start off with one reason why students may struggle with math vocabulary. So there are some math terms that are shared with what I'll call general English, but they have different meanings. So for example, if I talk about the word degree, so in math, I could be thinking about the degrees of an angle or maybe the degrees with temperature. But I also, outside of math, I have a degree when I graduated high school, or maybe some of you use a deodorant called degree. But what would you say are some other ways that there are math terms that are shared in English and then also in math, but they have different meanings? So a few that have come into the chat already is period and mean. Those are very good examples there. A second reason that students might experience difficulty with math vocabulary is that there's some math words that are shared with general English, and then we also see them in math, and they have similar meanings, but typically the math meaning is more precise. So one of the examples there is the word difference. So I live in the state of Texas. Probably most of you, live in the state of Pennsylvania or beyond. And so if I were to ask you, what is the difference between Texas and Pennsylvania? We would have a lot of different responses. You're still comparing those two states, but the responses would be different. But then if I asked all of you today, well, what is the difference between 11 and 5? Most likely all of you would say 6, right? So it has more precision with its meaning. So if you have some examples there, go ahead and drop those into the chat of words that are shared with general English and in mathematics, and they have similar meanings. Measure, it's similarity. We've got some good ones coming in. Another reason that students might experience difficulty with math vocabulary is that there's some math terms that are only used in math. And so it's likely that students come to your math classroom and they have no familiarity with this term whatsoever. It could be that for number one, students have heard the word degree before, or for number two, they've heard the word difference before. They've just heard that in their lives. But maybe students come to your classroom and they have never heard the word trapezoid or numerator or parallelogram. What would you say are some other math terms that are only used in math that your students don't ever know before you talk about it in the math classroom? If you've got some examples of those, go ahead and drop those in the chat. So we've got a good example of rhombus, another one of integer. Those are good examples. Denominator. Yeah, so lots of different examples there. Hexagon. Thanks for sharing all of those. That's a good list to look at. A fourth reason that students might have difficulty with math vocabulary is that there's terms in math that might have more than one meaning. So if I'll focus here on square. So here, when I think about geometry, I have the square that is a shape, but we also square numbers. And so just in math, I see that I have two, and sometimes there's words that have more than two meanings that are related to a mathematical meaning. If you have any examples of those, go ahead and share those with our group right now. We already talked about, earlier we talked about degree, and I gave two examples in math. And so you can see that some of these categories here overlap. So we just had a really nice example come into the chat, a quarter. Yep, yeah, we've got maybe like a quarter in terms of money and thinking about like quarter past or quarter till the hour. And also quarter in fractions. Oh my gosh, so many meanings of that word quarter. Now, a fifth reason that students might experience difficulty with math is that there's some math terms that they hear in the math classroom that they also might hear in other content area classes. For example, if I'm thinking about like maybe history or social studies, and we're talking about the continental divide, and then how does that relate? How is it kind of similar, but also different to the word divide when it comes to thinking about division? And then I saw some examples of these that got dropped in the chat, such as sum and rows and rows. But there are some math terms that are homographs. And so students may hear these terms and they may hear them as the same thing, but then they're actually spelled different and they have different meanings. I think some SUM versus SOME is a really common one. But I also could be talking about, oh, I've got the base of this three-dimensional figure, and some students might be thinking about a bass guitar, right? So there's a lot of different ways that I can hear those terms and they have different meanings, and that can cause confusion for students. A great example that just came into the chat is whole, WHOLE, and whole, HOLE. Wonderful example there. Now, a few other reasons that students might experience difficulty with math vocabulary is that there's math terms that they may hear in the math classroom that are related. So you often hear these terms, within the same minute, but they have distinct meanings. And we'll give some examples of these a little bit later in our presentation. There are also students that may speak another language at home or multiple languages outside of the math classroom. And so there might be English math terms that translate into another language and they have different meanings. Another reason that students might experience difficulty with math vocabulary is that there might be terms that are slightly different in terms of their spelling and how they're used. So like FOUR versus FORTY. Another reason that students might experience difficulty with math vocabulary, and we'll talk about this in our presentation here today, is that there's some math concepts that might be talked about in more than one way. I already talked about quarter past the hour or quarter till the hour, and that might be very confusing for students. Maybe they're used to saying 3:15 or 2:45. And then another reason that students might experience difficulty with math vocabulary is that they may be using informal terms for those more formal math terms. And so they may hear math vocabulary different at home than at school, or even different in school from maybe tier 2 intervention to the general classroom. And we'll give a few examples of those as we get through our presentation there today. Now, as I look at all of these 11 reasons why students might experience difficulty with math vocabulary, for the students that you're working with, it's often not just one of these reasons. You might say, oh, number 1 causes difficulty, number 2 is difficult, number 6 is difficult. And so a lot of times there's overlap in the reasons that students might have difficulty with math vocabulary. But I just present this list here to you today to really get you thinking about, well, what might be some of the reasons that students struggle with math vocabulary? And often, if you're aware of the reasons that students have difficulty with math vocabulary, you can get ahead, you can teach ahead of some of these errors, and also have really good conversations with students about, wow, we've got this word degree and it has all these different meanings. And let's talk about what degree means in the math classroom versus outside of the math classroom. So the 2 takeaways that I'd like you to think about today as we work through our session is to think about the use of formal math language. So your use of formal math language and your students' use of formal math language. And that formal math language is important because that's often what students are seeing and hearing on resources related to your textbooks or your curricula. And it's also how students are going to see math vocabulary on standardized assessments. Not that we're always thinking about teaching to the test, but it is an important way that students show their math knowledge, particularly starting in grade 3 and beyond. And so we want to make sure that students have had a lot of practice reading these terms, saying these terms, writing these formal math vocabulary terms, so that when they see those terms, they know what they mean. And then the second takeaway that I'll think about today, that I hope you will also think about as you leave this session, is making sure that we are using terms precisely. And this is particularly important when we have terms that students hear at the same time, and they may sound kind of similar, or may they look kind of similar. And we want to make sure that students understand the differences and similarities among terms that are presented at the same time. And I'll give some examples of that as well. All right, so let's go ahead and dig into some of these ideas. First, we're going to focus on the idea of formal math language. I'm going to pull a lot of examples from 2 articles that I had the pleasure of writing along with my colleagues, Elizabeth Hughes and Elizabeth Stevens. And if you ever want copies of these, just email me and I'll send them to you. Sometimes I know that these are behind a paywall and I'm happy to email you copies of both of these articles. But the first thing we want to think about is making sure that students are using and exposed to formal math language. And often that means that's going to come from you, their teacher, to make sure that you're using that formal math language as well. So what we'll see on these next few slides are some examples of informal language. That's with our red creature, who's here on the left-hand side. And then formal language, which is with our green creature over here on the right-hand side. And so the red creature is going to use the informal language, and then the green creature is going to say it just a little bit better to emphasize that formal language of math. So for example, if I was looking at this number 135, an informal way to talk about this number, especially with place value, would be to ask what number is in the tens place. Well, in reality, the number is 135, but what we want to emphasize is that 135, the number, is comprised of digits. And so instead of asking what number is in the tens place, let's ask students about what digit is in the tens place. When we get to comparison of numbers, this is a really common strategy to talk about that alligator that chomps that bigger number. Instead of asking students, well, which side of I guess those two numbers is this alligator going to eat? Remember, the alligator eats the bigger number. Let's use the more formal language. Let's say is less than or is greater than. So if I'm looking at 7 and 5, I would say 7 is greater than 5 or 5 is less than 7. If I'm looking at an addition problem such as this is a problem that involves some regrouping. And so instead of asking students to carry the one, that carrying indicates really just what you do with your pencil, let's talk conceptually about what's going on. Let's talk about regrouping or trading or exchanging. So if I added 7 plus 4 and I get 11, I would say, okay, I'm going to regroup that 110 to the tens column. So I'm going to use that more formal language. And also, if I had a subtraction example up here, instead of talking about borrowing, let's use the same terminology: regroup, trade, or exchange. The nice thing about these terms in green, and I see another term that came here in the chat, shifting. What we can do is we can use these for addition and subtraction. So there's more flexibility with these terms instead of just having a term for addition and a term for subtraction. And we can also use those terms, regroup, trade, and exchange, well beyond addition and subtraction as well. Now, when we think about fractions, there's a lot of informal language that might be used to describe fractions. So instead of talking about a fraction as having a top number and a bottom number, in actuality, a fraction is just one number. So 3/4 is a number, just as 1/3 is a number. And 3/4 is comprised of a numerator and a denominator. So let's emphasize that language. Also with top number, bottom number, many times fractions, we do present them with a fraction bar, but many times they're presented with a slash. And so there isn't always an obvious top number and bottom number. So let's use that formal language. Let's say numerator and denominator. If I am working with fractions and I'm asking students to reduce the fraction, that might actually indicate that I'm changing the value of the fraction, which we're not. And so ask students to rename this fraction, to simplify this fraction, to determine an equivalent fraction. If I'm thinking about decimals, so moving beyond fractions, if I want to help students understand the place value of these decimals, instead of saying, oh, that's 4.7, that's really just what you write with your pencil. Let's talk about it place value wise. Let's say, oh, that's 4 7/10. Or instead of saying, oh, that's 4.07, let's read it and say 4 7/100. When we get to geometry, there's a lot of informal language that we might use. So here, instead of saying that's a box, that's not a box, it's not three-dimensional. Let's talk about that. It's a square. And instead of describing that as a ball, that's not a ball, that is a circle. So get some good examples of instead of that, say this. And then here, instead of talking about this as a point, that's not a point, that's a vertex on that three-dimensional figure. And then if we get to transformations, often we like to call those flips, slides, and turns. But instead of calling them flips, slides, and turns, let's talk about them as what they are. That's a reflection, that's a translation, that's a rotation. In Texas, I think this is probably also true in Pennsylvania and some of the other states where you all live. There on our standardized test are questions about which of these is a reflection. It doesn't ask which of these is a flip. And so going back to that idea that students need a lot of exposure and practice to this formal math language, that's going to be a key component here. And then if I think about telling time, instead of talking about that long hand and that short hand, let's describe them for what they are. Let's talk about the minute hand and the hour hand. And so that brings us to an activity that we are going to do here. So you have a little bit of room on your handout packet, but you're also welcome to drop some of these examples in the chat. So I'd like you to take just about 2 minutes or so to come up with a few examples of instead of that, say this. So I'll give you some time to brainstorm. And then when you are comfortable, if you want to, please drop 1 or 2 of your examples in the chat. I'm excited to see what you've come up with. And I think all of the participants here will be excited as well. So take about 2 minutes or so to identify some examples of instead of that, say this. I look forward to seeing your examples. I'll ask you to drop those in the chat in just a minute. All right, we've got some great examples already coming in. So instead of bigger, say greater than, nice example. Instead of minusing, yeah, that's not even a word, right? Or taking away, let's talk about subtraction. Instead of the answer, say the sum or difference. That's a great example. We could also add product or quotient to that list. Instead of asking what is 4 plus 5, say what is the sum of 4 plus 5? Instead of ball, say sphere. Very nice. Instead of 120, say 120. And another one that comes up that I didn't include on the slides, but maybe some of you will get there, is not inserting that and. So a lot of people will say 120. No, it's instead of 120, it's 120. Instead of the bigger number, say greater number. Yeah, like that. And instead of times, say multiply. Yeah. So a question that's come into the chat is, can we say it our way to the youngest learners? Yeah, so there is a transition here from this informal language to this formal language. The teachers that we have worked with that really do focus on language in a really effective way do both. They might say, you're thinking about this as taking away, but this is also known as subtraction. And sometimes some teachers have said, well, our young kids, they're not really ready for the word subtraction. But I know a lot of 3, 4, and 5-year-olds who know what a Tyrannosaurus Rex is. And if you can say Tyrannosaurus Rex, you can definitely say subtraction. So the earlier we introduce it to students, but making that connection between informal and formal language, both of those things are going to be important. We've got some really good examples here. Instead of number sentence, try equation. Instead of the turnaround rule, use the commutative property. Very nice. Instead of PEMDAS, talk about the order of operations. Instead of a missing number, say a missing add-in. Oh, these are just wonderful. Thanks for adding to our list. I'm having a hard time keeping up with these. Instead of talking about a corner, talk about the vertices. Instead of asking students to reduce, talk about equivalent fractions. Instead of a larger number, say a greater number. Instead of a diamond, say a rhombus. That's a wonderful example. Instead of O, say 0. Ah, that's very nice. Instead of a 4-sided figure, say quadrilateral. Very good. All right. And Vanessa, there is a virtual handout for this session. It is in the Sched app, and maybe Melissa or Jared will drop that into the chat. All right, so those are some really good examples of thinking about taking our informal language and making sure that students understand and have a lot of practice with the formal language of math. And so what I'd like to talk about next is making sure that we're using terms with precision. And I'll give some examples of why this is important and what this might look like. All right, so we will go to the next page in our handout packet. If you're making some notes up there in the top rectangle, if you want to make any notes about terms in terms of thinking about precise language with math, that would be a good place to make some of those notes. All right, so let's talk about some terms that need to be used precisely. And this is one example which I have run into in multiple classrooms, and probably some of you, if you support students in grades 4, 5, 6, have also seen this error. So there is a difference between the word factor and the word multiple, but often students will treat these as almost the same term. And it makes sense because when we multiply our factors, but I might hear factor and multiple within the same lesson, maybe even within the same 5-minute span. But we want to make sure that students understand that there is a difference between what a factor means and what a multiple means. And you might say, well, Sarah, no, that kind of seems important, but I don't know if that's like the biggest thing that I want to focus on. It may not be the biggest thing you want to focus on, but having an understanding about the difference between a factor and a multiple is going to be important later on as students start to think about greatest common factors and least common multiples. Another example might be with fractions. Look at all these terms that we might use to describe fractions and fraction relatives. So we think about proper fractions, and then what is the difference or similarity between a proper fraction and an improper fraction? I do know that some school districts are moving away from talking about improper fractions with the idea that there's no fraction that's actually improper. And in those districts, they'll talk about these fractions that are equal to or greater than 1. But then if you are using improper fraction, or if you are using the language about equal to or greater than 1, how does that type of fraction relate to a mixed number? So there's some similarities and differences between those terms. And then if I'm thinking about multiple fractions, well, what is that? How does that relate to a proportion? How does a proportion relate to a ratio? And then I also have the term unit fraction. What does that mean? So students might hear these terms and they're like, oh, they overlap a lot. And they don't really see that there's a lot of differences among these terms. And so that's why we need to explicitly teach these terms and help students understand that we need to use some precision with all of these terms. Another example comes from algebra. So here I see an expression, and in this expression, we have a coefficient, we have variables, we have a constant, and then each of those constitutes within a term. So I've got these terms. There's another example where I have a general English term, and then I have mathematical terms. And do students know the differences among these terms? And then speaking of expressions, what is the difference between an expression and equation? What is the similarity and difference between an equation and a formula? Then students might often work with functions around the same time that they're working with equations. And then we have already talked about greater than and less than, but what is the difference or similarity between an equation and an inequality? So lots of terms that may be used in the same time for the same math content. Do your students know the differences among these terms? Now, when it comes to geometry, and probably many of you are already thinking about this, there's a lot of overlap in terms. And so just with the quadrilaterals, which I know someone said, hey, instead of talking about these as 4-sided shapes, let's talk about them as quadrilaterals. But when we think about quadrilaterals, there's a lot of terms to describe different types of quadrilaterals. So what are the differences and similarities between kites, parallelograms, rectangles, a rhombus, a square, and a trapezoid? And then there's overlap with these terms. So all squares are rectangles, but not all rectangles are necessarily squares. It really depends upon, the length of the sides of the rectangle. And so students, we can't just say, oh, these are all distinct terms. No, there's some overlap with these terms. When we talk about the shapes, such as our quadrilaterals, we might talk about the angles of those shapes. And so students need to know what's the difference between an acute angle, an obtuse angle, and a right angle. And then we also have a straight angle. That's something that students might be exposed to in the later grades. And then those angles relate to how we name, or one of the ways that we name triangles. So we have acute triangles, we have obtuse triangles, and we have right triangles. And then we also name triangles according to their sides. So equilateral, isosceles, and scalene. And here there is overlap. So every equilateral triangle is also an acute triangle. And then getting students to recognize, oh, I could name this by its sides. I can also name this by its angles. And many times they might do both. But look at all the language that students have to understand and digest in order to describe these triangles in an effective way. Now, speaking of angles, there's a lot more that goes on with angles. Many of these things are now coming into play in the middle school grades. But here I have adjacent angles, then I have alternate angles, then I have complementary angles and corresponding angles, and then supplementary angles and vertical angles. Wow, lots going on here. One of the things that I think is important to note is that some students may experience difficulty with vocabulary just because of the way that the words look. So if I look at complementary and supplementary, there's more of that complementary and supplementary. More of the term is the same than different. And so that could cause confusion. I also have terms that start with the same letter. For example, adjacent and alternate, or complementary and corresponding. Sometimes that might be a thing that can confuse students. And so what we have to do is really think about providing some really good explicit instruction on what are these terms, and giving students a lot of practice with these terms, not just listening to the terms, but giving students a lot of opportunity to use the terms in their speaking, to use the terms in their writing, to read these terms. We really want to make sure that students get a lot of access to these terms in many different ways. A few other examples here. So what is the difference between congruent figures and similar figures? What is the difference between a line of reflection and lines of symmetry? When we get to our transformations, we already talked about this in terms of instead of that, say this, but maybe really making sure that students know the differences among a reflection, a rotation, and a translation. And all three of those are transformations. And then kind of similar to transformations, what is the difference between dilation of a shape and scale factor? Continuing with our geometry for both our two-dimensional shapes and our three-dimensional figures, there's a lot of vocabulary that students have to be familiar with. So here with my two-dimensional shape, I've got sides, and those sides meet and create angles. And then I have different terminology when I think about the three-dimensional figure. So what is the difference between the edge, the vertex, the face? And then we also introduce this idea of the base. Many times that's used in some of the formulas that we use to calculate area. And so is the base a face, but not all faces are bases, right? So lots of things we have to get through there. Speaking of those three-dimensional figures, we have a lot of naming conventions that students have to learn to be able to describe these three-dimensional figures effectively. So here we see a cube. I also see a prism, a pyramid, a cylinder, and a sphere. And then we have names within these. So if I look at that prism, and I will say, yeah, that's a prism, but often we ask students, well, what kind of prism? So we look at the base of that shape there. I can see that that's a hexagon. So I would describe that as a hexagonal prism. It's not a triangular prism. It's not a rectangular prism. It is a hexagonal prism. And so giving students the wherewithal and the knowledge to be able to name these shapes, and then also distinguish what is the difference between a prism and a pyramid, and a prism and a cube. And then as we get into the later grades and we start to work with coordinate planes, this is just an example of some of the vocabulary that's necessary to solve a problem such as just maybe plotting that ordered pair here. So here I can see I've got my quadrants. I have the ordered pair there, 2, -3. And then I have X and Y. And then I have my X axis and my Y axis. And then I have the X intercept and the Y intercept. There is a lot of language that's going on here, and many students may not use these terms precisely, may not, they may have not had a lot of experience with these terms. And so we want to make sure to give them those opportunities. So what I'd like to do here is to have you open up the chat and open up the conversation to talk about some terms that you want your students to use with precision. So can you give some examples of terms that students confuse, or terms that students use at the same time and they may not know the difference between those terms? Like, what are you seeing in your experience of those terms that students need to understand with more precision? Take a minute to think about it and then open up the chat and go ahead and drop in some of your ideas. All right, as you drop in your ideas, a question came into the chat. I will work on that question now, and then I will share some of your precision ideas. So the question came into the chat. The question is, how do we ensure that our students understand math language when many of them are coming to us with fewer oral language experiences? Well, this is a really great question. So one of the things that we know about the learning of language in general is that the learning of language comes through experiences and interaction with language. And so, we may have a lot of students in our math classroom. Maybe you teach students that speak another language than English in the home, and so they haven't had as much experience with English math language. Maybe you have some students that have speech and language disorders, or students that have or experience dyslexia or dysgraphia. There's a lot of reasons that students might struggle with math language in the classroom. And so what we need to do, and hopefully this will be a takeaway from today, is really explicitly teach that language. Many math teachers teach math, but we'd really like our math teachers to also think that they are math language teachers. And so that is explicitly teaching vocabulary, having students create word walls, having students create glossaries, having students use certain terms in dialogues and in answers. A lot of the strategies that teachers are using in English language arts to emphasize vocabulary, we need to be bringing those into the math classroom and giving those students those experiences, because we do have a lot of students that just haven't had that much experience with math language or general language. And I would imagine that if we are emphasizing math language more in the math classroom, students are also going to be benefiting from with their general language as well. So that is a good question, and something we'll get into in the next few slides as we talk about some strategies to help with the teaching of language. But let's see some of your examples about using terms with precision. All right, so we've got at least 31 here, which I'm really excited to get into. All right, so terms that you want your students to use with precision. One example that has been put into the chat: the difference between the x-axis and the y-axis. Oh, I think that's probably a lot of middle school and high school teachers would shake their head and agree with that example. We have an example of the difference between divisibility and division. Another example we'd like our students to use with precision: numerator and denominator. Another example: what is the difference between a multiple and a factor? And another great one: what is the difference between a number and a digit? One of the examples that just came into the chat: what is the difference between a divisor and a dividend? I do not know who named those two things and why these division terms both have to start with D-I-V. It would be great if they had easier names. That's why quotient is easier to remember, but I think that's a great example, and really have to help students remember the differences between those terms. One example of like, I want my students to know all the different types of quadrilaterals. Yeah, we looked at 6. You might have some other names that you want to add to that list. What is the difference between a transformation and a translation? What is the difference between tenths and tens, or hundredths and hundreds? I find that one particularly hard because I have, just as even as an adult, I have a hard time saying that THS sound. So when I've taught students about decimals, I have to really emphasize, because I think my tens sounds a lot like tenths, and it's like very, very closely related. So we need to make sure we know the differences between those terms. Asking students to know the difference between factors of polynomials, zeros, roots, and intercepts. Asking students to know the difference among a mean, a median, a mode, and a range. Ask students in the youngest grades who mix up the teen numbers and the like 30 numbers. Yeah, so probably 13 and 30 or 14 and 40. Multiples and factors, I see at least 3 or 4 people have dropped that in there. And what's the difference between a corner and a vertex? What's the difference between a sum, a difference, a product, and a quotient? What is the difference between symmetry and partitioning? Oh, these are great. What's the difference between greater than and less than? Yeah, that can be confusing. Identifying triangles by sides and identifying triangles by angles. Yeah, and one of the comments that says there's never enough time for students to practice, and that goes back to what we'll get into with instruction here in just a minute, is that these terms are not going to magically come to students and they're not going to magically know them. All of this has to occur through modeling and practice. So, and yeah, there usually isn't enough time, right? That's a hard thing in the math. We have to teach so much within our math year, but we do need to make sure that we're trying to carve out at least some time for students to practice these terms. A few other examples that came in here. Instead of saying the difference between minus and takeaway, instead of takeaway, unit fractions and how they relate to proper fractions. The difference between expressions and equations, the difference between fraction versus unit fraction, regrouping and addition versus regrouping and subtraction. Difference as one of the ones. Yeah, so someone says the students don't always understand subtraction as the difference. And often that's because we've practiced subtraction as taking away so often that then we don't give students an opportunity to compare those two numbers and to think about the difference there. And a few others. I'm trying to see, I think I've said number versus numerals, subtrahend versus minuend, tenths versus hundredths. Yep, lots of things there. So one of the questions that came in is that geometry is so vocabulary heavy, but it's always rushed and glossed over. Why is that? Well, I hope some people will drop their ideas here in the chat. My hypothesis here is that geometry is one of those things that many times seems to come into play in the spring semester. We really focus a lot on any concepts at your grade level related to number and operations earlier in the year, and those are foundational and absolutely essential. And so I think by the time we get to geometry, there's a lot going on in geometry, and often geometry and measurement, data analysis are addressed in this at a similar time. And really, geometry is the understanding of vocabulary. And we just kind of like go into, oh, there's these 6 types of quadrilaterals and these 6 ways to describe triangles. That's a tremendous amount of language to ask students to be responsible before. But I think the placement of geometry in the school year often leads to rushing through it and helping, maybe not helping, but hindering students from really having a lot of practice with that math vocabulary. So as you walk away from today, I hope that you'll think about using that formal math language and using terms with precision. And so now I just want to turn our attention to, well, what should we do? We know that students have some difficulty with math vocabulary, probably for a number of reasons. We know that students may not get enough practice with math vocabulary. So now I'd like to think about, well, what does the research tell us in terms of the teaching of math vocabulary? And I'm very hopeful that many of you are going to add to this list of things here. So over on the left-hand side, I pulled some very common articles that are very prevalent in terms of, oh, we need to focus on math language. But all of those articles tell us that we need to focus on math language, but there's not that much research that tells us, well, what should we actually do about that? So I pulled in some citations here, and if you're interested in any of these, I'm happy to send them along to you that do give us an idea of what we should start to think about in terms of the teaching of math vocabulary, math language, and I hope you will add to this list. So one of the things that we've seen from several studies is the use of explicit instruction. I'll talk about that on the next slide, but it seems that when we explicitly teach these terms to students and we engage students in explicit practice of what these terms mean, that can lead to improvements in math vocabulary. Another idea might be to use semantic maps. So to help students understand, especially these terms that cause confusion, students don't use those terms precisely, semantic maps might be helpful to bring in here. Speaking of semantic maps, one study has looked at the use of visuals, whether that's a visual like a Freyer model or graphic organizer, or you might also want to use manipulatives or other types of drawings to help students understand what these vocabulary terms mean. We also see from the literature that using flashcards to practice math vocabulary has led to improvements in math vocabulary knowledge. And I saw a great example of this past school year in one of my research projects that I work on with a big team. We're doing a fourth grade fraction intervention. And before each intervention session, the teacher had fraction vocabulary terms written on flashcards and just hold it up, and the students would say it, and then they had to define it. Okay, what's the first word? Numerator. Tell me what a numerator means in your own words. Okay, what's the next word? Whole. Tell me what the whole means. What's the next term? Equal parts. And that seemed to really be helpful for the students in that, so that once they got into their fraction content, they had already practiced those terms at the beginning of the session, they had said them, and they had also defined them. What do those terms mean to those students? And then another idea here that you see here at the bottom is to use read alouds. So there are hundreds, if not thousands, of mathematics focused trade books that you can see in your school library or purchase online. And a lot of them lead to good conversations about math vocabulary. Use of read alouds is really prevalent in the early grades, like preschool, pre-K, first and second grade. But there's a lot of really great math books that talk about the Pythagorean theorem or proportional reasoning. There's a really good books about growing patterns. It gets into algebraic reasoning. So thinking about using read alouds, talking about the vocabulary in those read alouds, and then helping students understand how that vocabulary is important. And then Gina Nelson and colleagues just did a synthesis of math vocabulary studies. And I put them all here in this green rectangle on the side. But they noted that there's several trends that they see from the research that are important in terms of the teaching of math vocabulary. And many of these repeat with things we just went through. But they talked about using explicit instruction, using multiple representations. So those are drawings, manipulatives, graphic organizers, really carving out opportunities for students to discuss and then provide feedback to the vocabulary discussions. One of the things they talked about is that it's important to monitor student progress in terms of their understanding of math vocabulary. So what terms do your students know and what do they not know? And then they talked about coordinating vocabulary instruction across settings. So if you have some good relationships with science teachers or the reading teachers that you work in your school, could they be emphasizing math vocabulary in some of their instruction? And then finally, they said that practice is where it's at. And so we need to create a lot of practice opportunities for students. So digging into some of these ideas just with a little bit more detail. So some takeaways in terms of thinking about the instruction of math vocabulary. First, we want to use explicit instruction. So explicit instruction is a combination of modeling and practice with supports that are put in place, especially feedback as a support. On the right-hand side is an example from a first grade math vocabulary intervention. And you can see those are the 3 target words for the day: add, plus sign, equal sign. We're being very explicit with asking students to use those terms. Another thing that we see from the research is using some visuals to help students think about, well, what do these math vocabulary terms mean? Here are some examples of Freyer models or kind of like related Freyer models where students can write the word or the term, define it, draw some pictures, tell us examples and non-examples. And you wouldn't want to do these for every single term that's out there, but you might want to do these for some terms. And you can see an example for the word reflection. You may want to ask students to create different vocabulary cards, depending upon what the content is. You could also have students create their own glossaries. Here on the left-hand side is an example for glossary related to some algebra terms. Over on the right-hand side is an alphabetical glossary. And notice how many of these not only include the term, but some type of definition of the term, and often a visual. So you can find those visuals there. You might want to create a word wall. This is an example of a word wall that you can purchase, but probably better than this is creating a word wall with your students. So what are the terms that are coming up in your next unit? Having students write the terms, having students do some of the drawings, really getting students in the creation of a word wall. That would be a really cool idea. And then there was a thing that in the Nelson article, they talked about creating practice opportunities. So we can do practice as we are teaching in the math classroom, but we can also think about practice opportunities as through games or different activities. So here's an example of a seek and find and an example of a crossword puzzle. There are a lot of examples of these on the internet that you can either create yourself or print out and use in your classroom. So doing different types of word games is a good idea. And then there's also technology that can help us out here. Here are some different examples from the Math Learning Center and Math Lingo. Notice how the Math Learning Center, they're practicing math vocabulary, not only in English, but also in Spanish. But there's a lot of ways that we can use technology to emphasize and practice that math vocabulary as well. So now this gets us to the point, and I'm going to get into the chat and share some of the ideas. But what are some of the ways that you help focus on math language in your teaching? So please go ahead and start to drop some of those ideas in the chat, and I'll get caught up with you and share some of those out loud for our group. All right, all right, so we've got an idea of using songs. That's awesome. I love that idea. There's a lot of great songs out there. You could find a lot of songs on YouTube, and many of them might have videos that go along with them to help students understand math vocabulary. Another idea is to use pictures, right? Making this fun, getting students to draw or look at pictures and understand what the math vocabulary means. We have an example of you can use TPR, the total physical response, in teaching math vocabulary. One teacher talks about explicit instruction with visual examples. That's really helpful in terms of emphasizing math vocabulary. Another idea is having students keep a reference journal. We've done that in the past. We've created a glossary with a different letter on each page of the glossary. And as students learn a new term, for example, if they learn expression, they go to the E page, they write an expression, they write a definition that's going to help them remember what expression means. And often we encourage them to draw or make note of an expression. What would be an example of that? Another example that's come into the chat, acting it out. Yeah, this is great. And the role of gestures with math vocabulary probably cannot be understated. Especially even when I was talking about angles with all of you, I was like, oh, that's an acute angle, that's an obtuse angle. Like I really wanted to use gestures to go along with that math vocabulary. Asking questions in written form, all right. We got an example of twinkle.com has a lot of vocabulary resources. Getting students to practice the different syllables of math vocabulary, that's great. That's creating the word wall with the students and having them make that, and then taking that word wall and putting it into an interactive notebook. That's fantastic. And then a question comes, is there a list of math vocabulary by grade level? So I have one, which I'm happy to share with anyone. If you email me, I'll drop my email here in the chat. So the stuff that I showed you earlier when I said, oh, there's like 100 vocabulary terms at this grade level and 300 at that vocabulary or at that grade level, we put all of that information that we collected from several different textbook series into a single spreadsheet. And so the spreadsheet that I can send you just has the terms. I will tell you there's over 1,200 of them. And then what we have is whether those terms appear at grades K, 1, 2, 3, all the way through grade 8. So if you email me and just say, hey, Sarah, I want that vocabulary list, I'm happy to share it with you. We used it for research purposes, but I'm now happy to share it with anyone who is interested. A few other people talk about math journals. Some people like to talk about the etymology of the terms and how some of these terms relate to Spanish or French. Cornell notes, that's good. Prompting students to show off their vocabulary. You know, one thing that comes up with that is we are often in our interventions encouraging students to engage in discourse and discussion about the math vocabulary. One of the ways that you can make that a little bit better, say like, okay, I want you to turn and talk to your partner about this comparison of fractions, and I want you to use the terms numerator and denominator in your explanations. So giving students like a word bank to use in their discussions. It's also helpful if you're asking students to write in mathematics, to create a word bank. Here are some of the terms that you might want to use as you are writing these things. Nearpod, match cards. Yep, that's awesome. Great. All right, so a lot of really wonderful ideas have come into the chat. We're going to finish up here. I'm going to ask you one more question for today. So as we have put all of this together, I want to go back to this idea of the instructional platform. So in the instructional platform, we want to make sure that we are teaching explicitly. And one of the things you may want to teach explicitly is math language. And to help with the understanding of math language, you may want to bring in some of those multiple representations. So this math language is an important part of the instructional platform, and it's often going to be embedded in a lot of these other components of the instructional platform that we see there. So the last question that I have for you today is I'd like you to think about two things and then answer one thing. So I'd like you to think about, well, what are your strengths with mathematical language? Sounds like a lot of you are doing some really amazing things. So give yourself a pat on the back. What are you doing that's great? But then what's an opportunity for growth? Where's an area where you're like, I could do a little bit better with this? And so then the question that I would like you to answer in the chat today is, what is one of your immediate next steps? Maybe think about the next 3 months or next 6 months. What's a next step for you in terms of emphasizing the language of math? So think about those questions. And then if you feel comfortable sharing your immediate next steps in the chat, it might help a lot of us see, oh, I could do that too. So go ahead and drop those into the chat whenever you feel comfortable. If there are any questions, please go ahead and drop those into the chat as well.